Okay, hello everyone. So in this video, I'm gonna help you out with Sunday homework a little bit. Okay, so because in the class we discuss how to solve indefinite integrals using integration by substitution. But I'm gonna also show you how you can solve definite integrals using integration by substitution. Now, when I say definite integrals, that means we have limits here. So you are integrating from x values 0 to 2. Okay, so in that case, what are you going to do? Well, let's see. Okay, so we want to solve this problem using integration by substitution. So we need to choose a substitute. So what is our u going to be here? Okay, so we want to pick an inside function. So inside the square root, we can see we have 4 minus x square. So I'm going to pick that as my u. Okay, right. So if I pick u to be 4 minus x square, then I need du dx because I want to convert this dx to du. So if you differentiate u with respect to x, derivative of 4 is 0. Derivative of minus x square is minus 2x. So that means dx is du over minus 2x. Right, so we now have all the information we need to convert this integral into u. Okay, right, so it's x square root of 4 minus x square is u times dx is du over minus 2x, and you can cancel out x, and then what you got is square root u over minus 2 du. Now that's not the only thing we have to do here. Okay, so if this was an indefinite integral, well, yes, fine, but this is a definite integral. We have limits. Now if we say this integral is also from 0 to 2, that's wrong, because 0 and 2 belongs to x. Remember that. Okay, they are the limits belong to x. That means x values are between 0 and 2. But now what we have here is an integral in terms of u. U and x are not the same thing. U is in fact 4 minus x square. So you have to find the correct limits values corresponding to u. How do you do that? Well, you substitute these x values into the substitute and find out the corresponding u. That means the lower limit is 0. So when x is equal to 0, what is u? That's what we need to find. So to do that, we plug 0 for x. So 4 minus 0 square is 4. So u is 4. So when x is equal to 2, what is u? So you substitute 2 here. 2 square is 4. 4 minus 4 is 0. So u is 0. So the limits for u is now 4 to 0. And that's very important. Okay, so you can see the limits changed. Okay, when you're going from x to u. Right, now we can integrate. So 4 to 0, square root of u is u to the half over minus 2 du. So if you integrate u to the half, you get u to the half plus 1 over half plus 1. And also don't forget you have minus 2 on the denominator, and you're integrating from 4 to 0. Okay, there's no plus c here because this is a definite integral. So this is u to the 3 over 2 divided by negative 2 times 3 over 2, 4 to 0, 2 cancel out. So then we get u 3 over 2 minus over 3, 4 to 0. Now what you need to do is you substitute 0 and you substitute 4 for u and subtract. So if you substitute 0 for u, it's minus 0, 3 over 2 over 3. Now subtract by what you get by substituting 4. So it's minus 4, 3 over 2 over 3. Okay, so 0 to the power 3 over 2 is 0. So this minus and this minus plus. So it's 4, 3 over 2 over 3. So let's keep it like that rather than simplifying furthermore. We could, but that's the answer. That's the idea. So when you have a definite integral, what you ideally want to do is that you want to change the limits that belongs to x to the limits of u. To do that, what you do is you use the substitution itself. Okay, you use the inside function itself. Right, this is one example. I'm going to do another example. Okay. All right, so let's see a second example. So let me write the second problem as from 0 to pi e to the x to the x, 0 to pi e to the x cosine e to the x. Right, so this is the second problem. Now to do integration by substitution, I'm going to identify the inside function, which is inside cosine. We have e to the x, so I'm going to choose e to the x as u. So if u is e to the x, du dx is e to the x again. If you differentiate e to the x, it's e to the x. So then dx is du over e to the x. So our integral going to be e to the x cosine e to the x is u, dx is du over e to the x. These two e to the x cancels out. So then we are going to get cosine u du. Now at the same time, you want to change the limits, right? These limits again, as I said, belongs to x. So if x is 0, what is u? So if x is 0, u is going to be e to the 0, right? When you substitute 0 for x, it's e to the 0, and that's 1. So lower limit is 1. Now when x is equal to pi, u is e to the pi. Now that's kind of weird, but that's okay. I'm going to say it's e to the pi. Okay, right. So then let's integrate. So if you integrate cosine u, you're going to get sine u. Okay, and you are evaluating this from 1 to e to the pi. So now you substitute e to the pi for u, so sine e to the pi minus substitute 1 for u, sine 1. And this is the answer. There's no plus c because this is a definite integral. Okay, and this kind of like feels a little bit weird, the solution, but it is what it is. Okay, so the big idea with definite integral is that how do you change the limits, or you want to change the limits. Initial limits of the integration, okay, they belongs to x. Now when you change the variable, when you change x to u, you have to change the limits to u as well, and you do that by using the substitution. Okay, you plug the x values into the substitute and find the corresponding u values. So that's the idea. Okay, all right, so that's it for this video, and I'll see you in a next video. Thank you. Bye bye.